Agreed.
These partial fractions are kind of hard to do when you're not in a classroom setting and you're watching videos because they're totally different than anything we've done before. But compared to the trig stuff, I think at least it's better than trying to do all that, like those trig identities. Think if we had to do those in our virtual classroom, that would have been, I think, pretty difficult. So, all right, so we got 2x cubed minus x squared plus x plus 5, and you're dividing that by x squared plus 3x plus 2. So when you look at the fraction, before you automatically jump to the denominator and think factor, look at the power of the numerator and the denominator first. Josh, what do you notice about the power of the numerator and the denominator?
Then the top is bigger than the bottom, so you have to divide it.
Right. So when the top is bigger than the bottom, it's an improper fraction. And before splitting it up, we have to divide it to make it proper first. So a proper fraction is when the power on the top is smaller than the power on the bottom. And it must be a proper fraction in order to split it up and separate it. Otherwise, if you did it without dividing, your two fractions that you find will not create the original fraction that you're given. So if we divide this, when you divide, you take the denominator. You're trying to break down the numerator, so that's the part that goes underneath our division bar. And then with long division, which we did way back in chapter 2, you're only looking at the first term, and you're asking yourself, what do you need to multiply it by to make it 2x cubed? So Josh, what do you need to multiply x squared by to make it 2x cubed?
2x?
Yeah. So 2x, we can place that over the x term just to keep things lined up. And then you're multiplying 2x by everything that is out front here. So 2x cubed, positive 6x squared, and then a plus 4x. And with long division, everything is subtracted, which means if I distribute that minus sign through, it's a minus 6x squared, and then it is a minus 4x. So that really gives us negative 7x squared, negative 3x, and then I would bring down the 5. And then we start the process again. So we have now a negative 7x squared. We have the x squared, so we just multiply it by negative 7. And then again, make sure you're multiplying all of it. So negative 7x squared minus 21x, and then minus 14.
Do you have to do this every time the numerator is greater than the denominator?
Yes, that is correct. Yeah, so every time the numerator is larger than the denominator. So anytime it's considered improper. And if you don't, when you look at your partial fractions that you create, if you would find a common denominator and work through trying to check your answer to combine them back together, it would not go back to the original problem. So before you start factoring the denominator, just take a quick peek at the numerator and the denominator. So if the power on the top is bigger, then you must divide. If it isn't, then you don't need to do the dividing step. So if we finish this problem off here, subtract, again, it becomes a plus and a plus. You end up getting 18x and plus 19, which if I were working through this problem as a student 25 years ago, I probably would have been a little concerned because that's a weird remainder. 18x and 19, they're just kind of crazy numbers. Usually you have 2x plus 3 and that makes you feel better. But that's what our new denominator will be. So this remainder is part of the numerator, not denominator, sorry. So that's going to be our new numerator. What we divided out, we're going to forget about that. That's just the extra piece that got pulled out of the fraction that'll then go in our answer. So that's like an extra factor. We actually factored that out by using long division. So we'll just forget about that for a while and then put that in the answer at the end. So I'm going to take the 18x plus 19. That is our now proper numerator. And the denominator stays the same. So the x squared plus 3x and then plus 2. So this is the new fraction that we are going to be dividing with. And if you factor the denominator here, looks like a plus 1 and a plus 2. Does it matter which order you place the partial fractions? Like, does it matter if I put an x plus 1 and then an x plus 2 or vice versa? No, it doesn't matter. So if you have the x plus 2 first and then the x plus 1, that's fine as well. But what does matter is what goes on top. So if you have x plus 1, what goes on top of x plus 1?
A.
Yeah, nice. And it's linear, that's why it's just an A. And then on top of x plus 2 is just b. And I would say in most cases, if you have to do the long division, your fractions that you set up should be pretty basic fractions. So when I look at a over x plus 1, the common denominator is pretty easy to find here. So we're just multiplying a times x plus 2, b times x plus 1. So like the long division part's the hard part. Your Gaussian elimination should be the easy part after you break everything up. So 18x and 19. So then you've got ax plus 2a, bx plus b. And then just a little organizing, pulling the x's together. And then if it doesn't have an x, it's just a constant. So there we go. So finally, creating two equations. Maggie, what two equations would we have if we try and set this up as a system of equations?
18 equals a plus b, and 19 equals 2a plus b.
Yeah. So if I was looking at those two equations, if they both just have a b, b probably is easy to eliminate. So if I subtract this whole second equation and make it a negative 19, a negative 2a, and a negative b, then I would have negative 1 equals negative a, because the b's cancel, so a is just a positive 1. And then when you take that positive 1 and you plug it in for a, I now know that b is 17. So like that part was really easy compared to some of the other problems that were on the homework assignment. I think number 59 was probably the most involved problem, where you had a couple of equations to kind of solve for. So then when you write your final answer, don't forget about the part that we have way at the top in the numerator, because that's part of the final answer of our partial fractions. So that was the 2x and the minus 7. And then in addition to that, we have the 1 and the 17 that we just found for a and b. And the 1 goes with the x plus 1. And then the 17 goes with the x plus 2. So in Honors Algebra 2 right now, we're actually doing problems exactly like our answer. So the answer that I just found is what we're doing right now in Honors Algebra 2, where we're getting a common denominator, combining it together to go back to what our original problem started with. So you've come full circle now from last year in Honors Algebra 2 at this time to now this year in Honors Pre-Calc. You're kind of doing the opposite of what you did last year. Which, if you remember when you did foiling, probably pre-algebra you did foiling, and then you learned factoring. It's like the same concept here with partial fractions and finding common denominators. One undoes the other. So factoring undoes the foiling or vice versa. So, another question you'd like to go over from any or just general questions that you have about partial fractions?
Can you go over 58?
Yeah. All right. So 58, we have 3x cubed plus 4x. Not really worried about the numerator right now. But the denominator says x squared plus 2, or x to the fourth plus 2x squared plus 1. So factor first. How does the denominator get factored? So if you have x to the fourth, how would you factor that denominator? Anybody know?
Would it be x squared plus 1 and x squared plus 1?
Yeah, x squared plus 1, x squared plus 1. Because you have a 1 in the back, the only two ways to multiply to get 1 are 1 and 1, and the only way you can add to be 2 is 1 plus 1. And then to get that x to the fourth, we need an x squared. So because they're the same, we would write that as x squared plus 1 and then squared. So anytime factors are the same, we can combine them together to be one quantity, and then that quantity would be squared since it was repeated twice. So when you write your denominator, we really have two parts to the denominator. The first part of the denominator is just the actual factor, x squared plus 1. And a factor is whatever's in parentheses. So the factor is the stuff in parentheses, that x squared plus 1. And then the second denominator is still the x squared plus 1, but then it has the power of 2. If this denominator was cubed, then I would have a third fraction that said x squared plus 1, and then it would be cubed. So when you have something that has a power, it's called a repeated, in this case quadratic, and every power has to be written as a separate fraction. So after you write that part, this is a quadratic factor because it has x squared plus 1. It can't be broken down any further. On the top, when it's quadratic, everything that follows or is less than the x squared power needs to go in the numerator. So since we have x squared in the denominator, we need an x and a number in the numerator. And then same thing for the next one, the cx and then plus d. So anytime the denominator is quadratic, and quadratic in this case means x squared plus something. So it can't be broken down any further. You can't factor it or separate it. So any quadratic denominator will always be x squared plus 2, x squared plus 3, x squared plus 5, but it'll always be x squared plus something. And now we go to the thinking about common denominators. What do you have? What is it missing? So the first one just has the x squared plus 1, but it's supposed to be x squared plus 1 quantity squared, so we need another x squared plus 1. The second fraction has the entire common denominator, so it's just going to stay as cx plus d. So if we do a little foiling here, we end up with ax cubed, ax, bx squared, b, and then cx plus d. And kind of organizing these terms, ax cubed is by itself, bx squared is by itself, x has an a and a c with it, and then we just have the b and the d. So now separating ax cubed goes with 3x cubed. So without doing any work, I know a is 3. The next one, bx squared. Well, there's no x squared on the other side. So again, no work. We now know b is 0. The third one is our x term. So a plus c goes with the x which is 4. And then the last pair would be B and D. And B and D, well, there's no value, number by itself, so that just gets set equal to 0 as well. So even though we have 4 variables, you know 2 of them already, because A is 3 and B is 0. If you plug a 3 in for A, we now know C is going to be 1. And then B is 0. And if B is 0, and B plus D is equal to 0, that means D is also 0. So 2 of those pieces we actually don't use in the numerator. We're just using the A and the C value. So writing our final equation, we have an A of 3. That just goes with X. We don't have a B. We have a C value of 1. That just goes with X. And again, there's not a D. So you could check your work if you wanted to by like working backwards through the problem and saying, hey, I want to get a common denominator. So my common denominator would be this entire denominator, and like we could work backwards through the problem by multiplying this by x squared plus 1 and seeing if we could go back to the original numerator. But you can always check your work by trying to combine those fractions together by finding the common denominator. Other questions that you have about any of the problems? Yeah, number 59, sure. So looking at this denominator, Taylor, did you factor it?
I did. I had x squared plus 1 and then x plus 2.
That's perfect. Good. And then how did you separate it into the two fractions, Taylor?
I did ax plus b over x squared plus 1, and then
Okay.
I had the cx plus d, but then you said the changes.
Yeah, so the first one is correct. So we have the x squared plus 1. Again, that's quadratic because it has x squared. You can't break it down or factor it further. So the numerator has the ax plus b. And then the second one is just x plus 2. Since this is linear, we have to make sure that the fraction is a proper fraction. So the only thing that is smaller than x or a lower power than x would just be a c. So the only thing that can go on the top is a number, because if you have an x in the denominator, the only lower power than x would just be a number itself. So finding or applying the common denominator, this one gets x squared plus 1, and this one gets the x plus 2. Out of all of them, I think this problem you needed to do a little bit of extra work with like trying to eliminate some variables. So if we FOIL and then distribute, oops. Okay, so kind of separating our variables, we have an x squared that gets a and c. We have an x which goes with 2a and b, and then we just have that 2b and c by itself again. So now making our equations. One equation, a plus c equals 1, since there's a 1 in front of x squared. The second equation, 2a plus b equals 3. And then our third equation, 2b plus c equals negative 3. So if you look at those three equations, none of the equations have the same two letters in them. So unfortunately, you can't just like quickly eliminate and have just one variable left to solve for. So what I decided to do was to take the first two equations and eliminate the a. You didn't have to do it this way. That's just what I did when I looked at the problem. So I took the first equation and multiplied it by negative 2. And when you combine them together, the a's cancel. You end up with b minus 2c equals 1. And again, like this is just one way to solve it. So you could have chosen two other equations to try and combine together, but I just took the first two since they're the first two listed and combined them together. And then if you look at the last equation and the new equation that we just created, you can choose to eliminate b or c there. It's up to you. Let's say we'll multiply this one by 2. So if I multiply that by, how about negative 2? We have negative 2b plus 4c equals negative 2. And now I know c is negative 1. So once you know c is negative 1, I can go back into the first equation. A is 2. And then now I know that a is 2 into the second equation. I can find b to be a negative 1. So the elimination part in that problem was a little more involved than some of the other ones on this worksheet. So my final answer would be 2x minus 1. That goes along with the first denominator of x squared plus 1. And then actually the second one, since it's negative, I'm going to place the negative in between the two fractions and just a positive 1 on top. And that gets the x plus 2. So make sure when you're looking at the denominator, is it quadratic or is it linear? If it's linear, it just gets a regular ABC with it. If it's quadratic, that's when it gets the ax plus b. And then the other thing I think we talked about yesterday, the difference between x squared versus x squared plus 1. So this is considered quadratic. The first one is actually considered linear, even though for the last 3 years you thought of it as being quadratic. But the reason it's actually linear is because you could break that down as x times x, and both pieces of that are linear, whereas the x squared plus 1 cannot be broken down any further. So when it's linear, you would have an a over x and a b over x squared. When it's quadratic, you have ax plus b and then the x squared plus 1. So that would be the difference between the two denominators. Does that help with some of your questions?
Yeah.
Okay. Any other questions? No? So I will say that I think the rest of this chapter is kind of a repeat of the first part of the chapter. So if you remember at the beginning of the chapter, we did systems of equations. So the last part of the chapter is systems of inequalities. So you're going to be doing some graphing or looking at graphs, but it's that shading above, shading below. So that's the remainder of the chapter. And pretty much there'll be like a day or two of notes, probably 2 days of notes, and then like 2 days to kind of work on problems and review. That's how I'm going to try and set up the concepts that we'll be covering. Workload wise, do you like, is it too much work for math, or is it okay for math?
It's good.
I'm good.
Josh, you're okay?
Yeah.
Yeah.
That's fine.
Okay. Is it less work than what we would have done in school? Or about the same?
Probably about the same.
Okay.
Yeah.
Compared to your other classes? Like,
It's about the same
It
in
is?
our class.
Okay.
No, I usually get more in here than I do in normal in like every other classes.
Okay. Thanks a lot, Josh.
Yeah, I mean, but that's like expected because this is like one of the more important subjects. I guess.
Oh, well, I like you saying that it's more important. Okay. You can tell that to Mr. Kane, too.
Oh, I will. Get him on here.
Yeah, I should. I don't know what he's doing right now. He's crowd controlling with the girls, I think. They're actually playing Battlefront, I think.
Oh, yeah?
Yeah. My girls like their Xbox.
Yep.
Mm-hmm. That evil Xbox. Every day it's a battle.
I know. He was asking me my opinion on it way back.
Yes.
If he should get it for them.
And we did, and they play it, and they want to play it all the time instead of going outside or doing something else. But,
Yeah. You're welcome.
yeah, thanks. Thanks a lot. All right, well, if you have questions, send me an email, let me know. Otherwise, have a good day. I think the test or the quiz will be uploaded momentarily. So you can feel free to take it whenever. You have till...
We don't have any homework tonight, do we?
No, just besides doing the quiz by the end of the day tomorrow, like 11:59 p.m. tomorrow. And that's it.
All right.
Okie doke.
Thank you.
All right, have a great one.
Yeah, you too.
You
Thank
too.
you.
See ya.